Hello everyone, my name is Wataru Chino, SensinGoodLab in Japan. We are developing a device for the visually impaired that uses QZSS positioning information. We entered S Booster 2019 under the category of space utilization because we wanted to accelerate the process by obtaining development funds. Because we've been working on this project only with our own funds, since we each have other jobs. So today I would like to talk about our project and what we have obtained from joining the S Booster. Our mission is to create a work that encourages people to take the first step. And at first, we are working to realize our vision of a society where the visually impaired are a natural part. My wife's grandmother's accident was the reason why we started our activities. She had an eyesight. When she was walking beside the river, she missed her footing and fell and died. I thought if there are people who are grieving or suffering because of the working which we usually act, I would like to solve their problem. That is why I started our activities. For the severely visually impaired, every day is within a risk of their life. In fact, half of people experienced an accident and 4 out of every 5 people get injured while walking. There are currently 200 million such people in the world. The number is expected to increase further due to the aging of the population. This is a service they usually rely on. There are only 1,000 guide dogs in Japan, and guide helpers have limited availability in Japan. Therefore, they are not free to go out. We had further discussions with them. In their working, they often find it difficult to identify intersections and traffic lights, which makes them feel dangerous and uneasy. Also, when they go to a new place, the action of talking to people is always needed. However, many people feel difficult to talk to strangers whose faces they cannot see. So they choose to go out alone only the same place on the same street and to go to new place with helpers. However, the number of helpers is decreasing due to COVID-19. So they are giving up going out in many cases. In addition, people who used to be able to talk to others are now reluctant to do so because of the COVID-19, thinking that the other person might not like it if they talk to them. We will solve this problem that people not being able to get to their destination safety without getting lost. So we propose this solution. This is a three-dimensional wearable device that attaches to shoes. The device is made of a soft material that is inserted into the shoe, and a controller part that contains the main board. The controller part is equipped with internal sensors such as motion sensor and external sensors such as and cameras and GNSS receiver and Bluetooth. The yellow part, which plug into the shoe, has vibrators in the heel, side, and instep of the foot. This makes for an intuitive and understandable vibration user interface. The function provided is navigation with a vibration interface from the feet up. At intersections, the system guides the user to step. user to stop, regardless of whether he is going straight or turning right or left. This allows visually impaired people to confirm that their perceptions are matches with the surrounding environment, and to check the safety of their surrounding appropriately where necessary. The front area vibrates according to the walking speed to guide the user to go to straight. Near intersections, all area vibrate to guide the user to stop. When making right or left turn, side area vibrates, and then switching to instruction to go to straight with monitoring body direction. Like that, we have combined vibration areas and vibration tempo to generate instructions as simply as possible. We have demonstrated that the system can guide the user without training. Let me explain the point of why we use the feet as an interface when we talk to them. What struck us most is that they are working with their ears, hands, and sole of their feet in a very sensitive way. They tap their cans on the ground and use the echo sound to detect walls and parked cars, or use their cans to grasp the road surface. So we proceeded to verify where not to disturb them, and we were able to create an interface that can be clearly and intuitively understood by vibrating along the nerve phases of the foot. There is a technical problem with navigation for the visually impaired. This is the positioning error in existing positioning systems, such as GPS. In fact, when I hold on an existing product and use voice navigation, it tells me that I have walked 100 meters, even though I have only walked 10 meters, and the direction reverses 180 degrees. So we choose to use QZSS. QZSS is a Japanese satellite positioning system consisting mainly of satellites in quasi-zenith orbit. Currently, we are planning to use L1S reinforcement signals, but as L6 reinforcement signals receivers are getting smaller, we will consider using L6 signals for even higher accuracy, depending on the cost and size of the product. First of all, we can improve the base accuracy by using QZSS in addition to the existing GPS, etc. However, even with QZSS, errors may inevitably occur due to multipath and weather effects. Under such conditions, in order to obtain the accuracy necessary for guiding the visually impaired, we supplement the accuracy with depth reckoning for walking, which is based on automotive driving technology. This method uses motion sensors such as accelerometers attached to foot device and external sensors such as cameras to capture foot movement and calculate accurate walking trajectories, thereby, thereby reducing GNSS errors. We are developing this method so that locations such as intersections can be identified with high accuracy. We use this solution to encourage people to want to go somewhere and give them a sense of accomplishment by helping them take the first step. We hope to we hope to realize our vision by providing a series of experiences in their lives that foster self-confidence. We are a team of two Honda engineers and an IT engineer. We have entered several business contests, but we have accelerated our development with the prize money we won in the biggest contest as booster. We have been working on a limited basis as a side business, but we are now going to incorporate and promote our business. Our participation in S Booster has given us not only the prize money, but also the support of various people, especially the Japanese cabinet office. For business that are not in the space domain, it is very difficult to utilize space technology because it is not only highly specialized, but there are many things that we cannot control. Therefore, the benefits of receiving this kind of support are very significant. By utilizing these advantages and forming a businesses with products for the visually impaired, we will establish high precision positioning technology, image technology, and user interface for walking. Then applying this technology and know-how, we will ultimately update the walking navigation system to provide various value. Thank you very much.